Okay, are you familiar of what are you seeing? These two reactions? You should be. You will learn this in the reaction of alkene 2 chapters ago, right? When you do add hydrogen and bromine, so it's go Markovnikov fashion. Bromine go to more substitute carbon. But if you add a peroxide, it will go in reverse. So go anti-Markovnikov addition. Bromine go on to less substitute carbon. Let's explain why it happened. Finally, we can explain this. So this reaction actually go radical mechanism. Let's take a look. Okay. So we're gonna draw the radical chain reaction. Start with initial, propagation, termination, reaction after reaction. It's a chain reaction. That's why we call it chain reaction. Anyway, so that's the reason why we have to add light to break the peroxide, right? The whole goal of initial step is to make a bromine radical. Let's see how to make bromine radical. All right, so break this bond apart. So you should get two equivalent of the OR radical, oxide radical. All right, and the oxide radical will go attack HBr, and that's how you get a bromine radical right there. All right, and this bromine radical we go to reaction and propagation. So again, propagation, so radical attack non-radical. So bromine have two options: either attack less substitute carbon or more substitute carbon. Which one will produce more stable radical? I'm going to ask you one more time. So bromine radical got two options: attack less substitute carbon or more substitute carbon. Which one's better? Well, let's take a look. So bromine radical will actually attack the less substitute carbon because this attack will produce tertiary radical, the more stable radical. If bromine attack carbon in the middle, the tertiary carbon here, the radical that you're gonna form is primary, which is less stable. And you guys know bromine is really selective. All right. If they go the other way around, so we form the less stable carbocation radical. This radical will form the Markovnikov product, which we don't observe that, right, in the presence of peroxide and light, right? So it go this way. All right, this guy will go grab the hydrogen from HBr. Here we go. That's the product. Okay, so if you have to explain why the adding peroxide, adding light, and this reaction go Markovnikov, what controls the radioselectivity, the stability of the radical, right? Bromine can attack more substitute carbon, but you're gonna form the less stable radical, right? So bromine gonna go attack the less substitute carbon to make more stable radical. All right, so we get the product now. So we're going to go to termination. Just mix them up. You can do this guy, mix with this, or attack itself, whatever here. Just show you right there. What else we have? Bromine and bromine. And that, okay, right there. All right. All right, that's the reason why, okay? Now, let's try this. So what product did you get here? So this is anti-Markovnikov. So bromine is going to go on to less substitute carbon, so that position. Okay, so first of all, you're gonna get this radical. You should get this radical right there, and then the radical right here on tertiary carbon, and this radical go get hydrogen from HBr. So you should get this compound. Watch out though, when you do this reaction, a new chiral center is formed, so you should get two products here. Okay, so watch out for the chiral centers. All right, last video of this